Good morning, sir. This is P. Bharat Kumar from the Department of ECE. My roll number is 2340180416 and the subject code is 23 404. Today my topic is gain margin and phase margin. Gain margin and phase margin. Introduction to the gain margin and phase margin. Gain margin and phase margin are essential concepts in control systems. They help in assessing the stability of feedback systems. Understanding these measures is crucial for designing robots control systems. Definitions. Gain margin is the amount by which the gain of a system can be increased before it becomes unstable. Phase margin is the additional phase lag required to bring a system to the verge of instability. Both margins are typically expressed in deciabels dB for gain and degrees for phase. Importance of gain margin. A high gain margin represents a stable system that can tolerate vibrations in gain. It provides a buffer against parameter changes and uncertainties in the system. Engines of aim of the gain margin greater than 10 dB for robust performance. Importance of the phase margin. A sufficient phase margin ensures that a system can be withstand delays and phase shifts. It often linked to the transient response of the system. A phase margin of at least 30 degrees generally designed for sustainability, and this is the graph of the 30 degrees phase margin frequencies. Measuring gain margin. Gain margin measures using both ports of Nyquist plots. It is determined at frequency where the phase cross 180 degrees. The gain margin can calculate as the reciprocal of the gain at this phase crossover frequency. Measuring phase margin. Phase margin is also determined from board of Nyquist plots. It is measured at the frequency where the gain cross 0 dB. The phase margin is difference between the actual phase and 180 degrees at this frequency. Relation between gain margin and phase margin. Gain margin and phase margins are related and affect system stability together. A decrease in a gain margin typically leads to a decrease in a phase margin. Both margins can be adjusted through controller design and system tuning. Stability criteria. A system is considered stability if both gain margin and phase margin are positive. If either margin is negative, the system is unstable. System with low margins may exhibit oscillatory or undesirable behavior. Practical applications. Gain and phase margins are used in designing PID controllers for various systems. They help engineers predict how system will be respond to change and disturbances. These concepts are applied in industrial such as aerospace, robotics and automotive. Conclusion. Gain margin and phase margin are vital for ensuring system stability and performance. Mastery of this concept is essential for the control system engineers. Ongoing analysis and adjustments of these margins contribute to effect system design, and this is the gain margin and phase margin of explanation and conclusion. And this is the graph of the phase margin and gain margin we have seen in this PDF, and contribute to effect of the systems of gain margin and phase margin is very crucial. Reference. Thank you, sir. Thank you for giving this opportunity.